Hello there, welcome to the A-Level Maths Pure Paper 2, June 2023. Here we're looking at question 6. Relative to a fixed point O, we have these positions A, B, C and D. Show that AD is parallel to BC. Okay, so let's do that. So A to D is calculated by doing coordinate D minus coordinate A. I'm going to do this as a vector. So D is 22, 24 minus A, which is 12, 0. And when I subtract those two, I'm going to get 10, 24. Okay, let's now do BC. So I'm going to do C take away B. C is 50, 136. And I need to minus 16J, which would be 0, 16. So I get 50, 120. So these two are definitely going to be parallel. They are parallel as 5 lots of AD. If we multiply the AD vector by 5, we get BC. And that is a definition of a vector being parallel if one is a multiple of the other. Okay, good stuff. Let's move on to the next part then. Points A, B, C and D are used to model the vertices of a running track in the shape of a quadrilateral. Runners complete one lap by running along all four sides of the track. The length of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, calculate the average speed of this runner, giving the answer in kilometers per hour. Okay, so what we'll first need to know is how to get from A to D. So A to D is going to be, 1024. So the distance of 1024 is 10 squared plus 24 squared. So let's work that out on the calculator. 10 squared add 24 squared, which is 26. And that's 26, meters. Then we already know B to C. So that is going to be 50 and 120. 50 squared add 120 squared, which is 130, pretty sure, without needing to use a calculator. Okay, so we've got, we need to now work out the distance around the track. So we've got this A to D is parallel to B to C. So I reckon they would then go from D to C and then B to A. So D to C is the next vector we need to work out. And D to C is going to be C minus D. So 50, 136 minus 22, 24. So that is 50 minus 22 is 28. And 136 minus 24 is 112. And then the distance of this, 28 squared add 112 squared. 28 squared add 112 squared. The square root answer gives 28 root 17. And then the next vector we'll go along is, they'll go backwards that way and then forwards up this way. So from B to A. So B to A is A take away B. So 12, 0 take away 0, 16, which is going to be 12 minus 16. And the distance of that, 12 squared add 16 squared, is square root answer is 20. 12 squared add 20 squared equals, 16 squared equals 20. Right, so we've got all of the meters now, so let's add all of these up together. So it's 26 add 130, add 28 root 17, add 20. Whoops, that 20 went inside the square root, which you shouldn't do. Add 20, so 291.4 meters. Right, okay, so 5 minutes. Let's convert all of this into kilometers first. So how many kilometers is this? This is 0.2914. So I'm going to divide this on my calculator by 1,000. And 5 minutes is 1/12 of an hour. Right, okay, so before I move on to calculating the answer, it says complete 2 laps in 5 minutes. So this is the distance for 1 lap. So I'm first going to do 0.2914 times 2, which gives an answer of, let's work that out, which is 0.583 kilometers roughly. And now we're going to do 2 laps divided by 5 minutes. So that's 0.583 divided by 1/12 of an hour. So I'm going to times this by 12 on the calculator. I get 6.99 kilometers per hour. And there we are. That's the answer for question 6, worth a total of 6 marks. Let's now move on to question 7.